All right, well, let's step it up a notch where we're going to solve some rational equations, but this time we might have some extraneous solutions that cannot be. So we're going to have a little bit more complicated rational equations to deal with here too. So we got 2x over x plus 3 plus 3 over x plus 6, and that's going to equal supposedly 27 over x squared minus 3x minus 18. Well, in order to add those two equations, I've got to have a common denominator. But you know what? When I look at that x squared over here, x squared minus 3x minus 18, you know, I could factor that. And if I did, my last term, my constant's negative, so I know I got to have a positive and negative inside my parentheses. I need two numbers that are going to multiply to negative 18 and add to negative 3. And well, let's see, x minus 6, x plus 3. Well, Shazam, that's pretty close to what I got there, isn't it? All right, well, let's see. Let's multiply this 2x over x plus 3 times x minus 6 over x minus 6. Yeah, over x minus 6. Multiply that times 2x over x plus 3. And then plus, we got the 3 over x minus 6. Let's multiply that times x plus 3 over x plus 3. And that's going to equal 27 over, well, x plus 3 times x minus 6, which is x squared minus 3x minus 18 if I FOIL that. All right, so let's see. Now that I'm going to end up with, that should be 3 right here, not 2. All right. Now that I'm going to end up with a common denominator, I really only got to focus on the numerators. So let's distribute 2x to the x minus 6, and so that's going to be 2x squared minus 12x, and then plus, let's distribute the 3 to the x plus 3, 3x plus 9, and now that equals 27. And I'm still going to have to take into account for my denominators because that's where my extraneous solution may come in. We're going to see that a minute later. All right, so let's combine like terms here. So I've got now 2x squared. Negative 12x plus 3x is negative 9x plus 9 equals 27. And let's subtract 27 from both sides. And once we do, that should be squared. 2x squared minus 9x minus 18 is now equal to 0. All right, so I need to think about factoring that 2x squared minus 9x minus 18. Well, it's a 2x squared, so I know I'm going to have a 2x on one side of my parentheses and x on the other. All right, let's see, negative 18 plus 9x. I'm thinking, so I've got to have a plus or minus in here, don't I? I'm thinking 2x plus 3, x minus 6. Okay. Let's see, 2x times x is 2x squared. 2x times negative 6 is negative 12x. 3 times x is positive 3x. 3 times negative 6 is negative 18, so I got the negative 18, and then I'd have negative 12x plus 3x. Yeah, okay, that falls back to 2x squared minus 9x minus 18. Let's set each factor equal to 0. And x minus 6 equals 0. Let's subtract 3 from both sides on this one. So now I got -3, divide by 2, and I got -3 halves. And now I got to take that -3 halves and think about plugging it into each of all the denominator. Well, it doesn't make x plus 3 go to 0. That's what I'm trying to avoid. That's what would create an extraneous solution, something that would still end up making me divide by 0. And -3 halves doesn't make the x plus 6 go to 0. So this one is a valid solution. What about the next one? Add 6 to both sides. 6 minus 6, right there. Right there. That'd make that 0, and that'd make the whole thing go to 0, and it would make it all go to 0 right there. And so that is not a valid solution. So my only solution then is -3 halves. Yeah, like I said, we're stepping it up a notch. These are a little bit more complicated. So let's do one more just for fun, because these really are kind of fun. Okay, so I got 12 over x squared plus 6x equals -2 over x plus 6 plus x plus 2 over x. Well, what's one of the first things if I'm looking to factor something, what's one of the first things I want to do? I want to see if I can factor out a common factor. And I think I can over here on the left. That would be 12 over x times x plus 6, right? Now, so what am I missing over here where I got a denominator of x plus 6 where I can get to a common denominator? Well, just an x. So let's take this -2 over x plus 6, and let's multiply that times x over x. How about that? And then plus, where I got x plus 2 over x. What am I missing there? What factor am I missing? Well, I'm missing x plus 6. So let's multiply this by x plus 6 over x plus 6. Now I would have a common denominator in all three terms, which would really end up being x squared plus 6x, right? You agree? You should. So I don't have to do anything over here to the on the left side. So I'm just going to set this is equal to 12. Now that's equal to, well, let's see, -2 times x is -2x. And then x plus 2 times x plus 6. So let's see, let's FOIL that. X plus x is equal to x squared. X plus 6 is plus 6x. 2 times x is plus 2x. And 2 times 6 is equal to 12. Yep, plus 12. All right. So now what? Well, let's combine like terms. So, well, we'll leave this at 12 for the time being. And then I'm going to write this in standard form. So I've got x squared, -2x plus 2x. Those are going to cancel. It's going to leave me with 6x, right? Plus 12. Now we're going to subtract 12 from both sides. And so 0 is going to be equal to x squared plus 6x. Well, I can factor that. I've already done it once. So let's see. We got 0 equals x times x plus 6. All right, let's set each factor equal to 0. Well, if x is equal to 0, what's going to happen here? Well, if I look right there, that's a 0 right there. I'd have to plug in a 0. I can't do that. So that cannot be a valid solution. What about the next one? X plus 6 equals 0. X is equal to -6. Well, what if x is equal to -6? Well, that'd be negative 6 plus 6 right there. That'd be 0. And, of course, all of that would be 0. And so that's not a valid solution either. And so on this one, there is just absolutely no solution. All right. That went by a little bit fast. You know what? Watch it again. You got to get it to a common denominator. Once you figure out what's missing from each piece, you multiply that. Like in this case, x over x, or x plus 6 over x plus 6, which really be in either case just equals to 1. You solve. Once you get a possible solution, you plug it back into your original equation, see if any of that's going to make you go to 0 if it in the denominator, and if it does, it's not a valid solution. Have fun.